Consider a virtual reality system developed for training software development and software architecture basics. It includes a virtual surface and virtual objects created from software statistics and a gesture interaction system. The user wears a head-mounted display, and uses two hand controllers in order to interact with the room-scale virtual environment. The HMD and controllers communicate 3D coordinates of the user's hands and head to the VR system. Coordinate data are used to interpret actions of the user. What we see here are objects representing code files. In the case of Java, they represent classes. The height of the objects, y, has two values, which creates sharp endings of concave polygon shapes. It represents lines of code, y1, and lines, y2, which is more or less higher number because all the comments are counted in. The width, x value, maps the statements used in Java file. The depth, z, value, represents methods. The color changes from green to blue gradient getting more intensive, as it is covering a base of the objects. The text layers tell us that the gradient color represents the % amount of comments in the file. Pointing at the diamond-shaped objects reveals a label which shows information about smells, based on metrics from Sonar. The text reveals when the small L was detected, by whom and in which code row it is to be found. There are buttons on the table, resize and play. Pressing resize creates the same objects 10 times bigger around the user, who can now walk around and examine also the small objects properly. Pressing play activates a raycast which slowly goes through the objects from right to the left, activating them. Each part of the objects play its sound.
What is the red thing there?
The smelly wall.
What are smells?
Code smells are automatically detected by Sonar, and are defined by its documentation as a maintainability-related issues in the code. Leaving smell it as is means that at best maintainers will have a harder time than they should making changes to the code. At worst, they'll be so confused by the state of the code that they'll introduce additional errors as they make changes.
So what will you do?
I will climb on them.
Yay! What is going on?
I am fighting bugs through the method of climbing refactoring through dependencies.
What are dependencies?
Whenever a class A uses another class or interface B, then A depends on B. Two classes that uses each other are called coupled. The coupling between classes can be loose or tight, or somewhere in between. This one is quite tight. Dependencies can cause complication because they decrease reuse.
Okay.
In front of the user are terrains which represents a specific software directory. There is API, Business, UI, Util, WebApp. Terrains are in A the size of islands, its files are peaks, where height, Y, represents lines of code. The width, X, are statements and depth, Z, are methods. One terrain, in this case a utility directory, is displayed as a small model in the table size in front of the user, and all 5 models are around the plateau as big walkable terrains. With the right controller she points to the small terrain and the outlines of a square prism are highlighted, on the small as well as on the big model. A text label appears on the top of the prism, which shows information about the file. Simultaneously, a screen is shown where she can scroll up and down through the source code of the highlighted file. She can walk around the small model. With the left-hand controller, she can also teleport in the further locations. There are cubes with icons and labels of all 5 terrains which work on click as direct teleports to selected terrains. The terrains have different colors, which represents the test coverage data. Where there was no unit tests, the terrain is black. Where it has been tested, the color and additional objects show the results of testing. Green slot means tested, a text node shows the result of testing, and a floating circle, similar to a 3D pie chart diagram, represents the percent value of unit test. Where there was a unit test written but covered 0% of code, the area is red.
Where are you climbing now?
You can even explore package hierarchy and inheritances. What you can see here are procedurally generated 3D meshes and textures according data out of 12 different snapshots of project development. Static visualization of the software evolution is generated out of metrics concerning different quality requirements. Monitored is, for example, the amount of duplicated code, duplicated lines and blocks, security rating, technical depth ratio and code smells, as well as already presented metrics about coverage and so on. All of the metrics definitions are displayed on the top of each metrics snapshot scala. And now, head to the VR and try the soft world by your own.